Okay, we got this relationship here we need to verify. Here's the data points. So we can take logs. So log of f then will equal log of the c plus, and this will be log of p to the k, which we can write as k log p, can't we? So log of f equals k log of p plus log c. And if we compare that with y equals mx plus c, then we can read off the correspondences. We need to plot log f against log p here and get these data points. Log p will be the x-axis, log f will be the y, and in that case the gradient m will be the value of k, and the intercept c will be the value log c here in this case. So let's do that then. So let's put this around the other way. Let's put that below. Okay, so log of 10. So calculator, let's tap them in then. So the first one, log 10, log base 10 of 10 is 1, which we know. Then log 16, 1.2. Then log 25, 1.4. And then log 40, 1.60, and then lastly log 60, and log 60, 1.78. Okay, now we do log 94, 1.97, log 118, 2.07, and then log 147, 2.17, and then log 180, 2.26, and lastly log of 230, 2.36. So these are the points we need to plot on the graph to get the gradient and the intercept. Let's have a go at that. Here. So we're plotting log p against log f. Log p is the x-axis and log f is the y. Log p goes up to 1.78. So 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 0.2, and that would be log p, and then log f goes up to 2.36. So 0.4, 0.8, 1.2, 1.6, 2.0, 2.4. There we go. So the first one is at 1 and 1.97, which I would say is about here. Then 1.2 and 2.07, just about here. And then 1.4, 2.17, and then 1.6, 2.26. Say, oops, a bit high that one. and then 1.8, 2.36, which is just about here, hopefully. So I can draw a straight line now, as best I can. Let's have a look at that one. Bit high, come down a bit. Well, that looks okay. Yeah, I'm okay with that one. So there's our line of best fit. Then this value here we need to read off. That's 0.8, that's 1. So say it's 1.1, just a smidge above perhaps. And then if we draw a triangle out to 1 here, so drop it down at 1. It's easy to divide by 1, isn't it? So it's a nice generous triangle as well. This height here looks 1.1. This height here is 1.8 perhaps, just a guess there. So the height will be 0.7. So the gradient is 0.7 over 1, which is 0.7. The intercept C is equal to 1.1. So here K is 0.7 and log C in the original is 1.1. This is log to base 10, so it's 10 to the 1.1. Okay, so C would equal then 10 to the power 1.1. 12.5, 12.6. So there's our value of C in the original. And F equals CP to the K. F equals C P to the K. And what was K? 0.7. So that's what we've got then in that question for 5. And we found the values in question 5. So I'm quite a way out here for some reason. I seem to have plotted it quite wrongly actually. Log base 10. I thought it was log base 10. Yeah. Okay, well my answers differ wildly from the original, because the original is F equals 30.2. This is in the notes, P to the 0.491. So I'm way out here with my little sketch. So it'd be interesting to see what you get when you do a proper graph and see if I've made some sort of error here. Certainly I've made an error in terms of accuracy, but I'm not sure whether I've made an error in any other respect, because it does look rather quite different from what you'd expect in terms of the solutions in the notes.